General mission planning. There are two types of missions to plan. Missions to cover surfaces and missions to cover linear corridors such as roads, paths, riverbanks, or power lines, among others. Missions that aim to cover surfaces are carried out by drawing equidistant parallel lines, and keeping the height of the aircraft constant in relation to the ground. The turns required by the aircraft to move from one flight line to another are drawn outside the area of interest, in order to exclude this information from processing. This is because the greater the movement of the vehicle, the greater data contains an angular variation in the results. The distance to separate these turns must be at least half the separation between flight lines. The zones close to the edge of the area of interest must be within two parallel lines, so that the information is covered with overlap between these two lines of flight. Do not leave areas that are covered by only one line. When multiple flights are required to cover the area between consecutive flights, the same line spacing must be conserved. When several flights are required to cover the total area, a subdivision of the area of interest is made into several polygons, considering keeping the flight lines equidistant and, as far as possible, aligning the lines between consecutive polygons. In linear corridors scanned using a drone, two equidistant lines parallel to the axis of the road are made. One line is drawn in one direction, and the second in the opposite direction to overlap the elements located on the axis of the road. In linear corridors, a curve can be made for changes of direction equal to or less than 45 degrees, with a maximum radius of 20 meters. For changes of direction greater than 45 degrees, make a turn in the opposite direction with a radius equal to or greater than 30 meters. This is in order to process the data with straight sections, excluding turns with a radius of 30 meters. For drone flights, the height, the speed, and the distance between lines are defined using the point density calculation wizard, located on the website lideratexperts.com/manuals. In this wizard, the fields shown in red are used to enter the necessary data for the calculation, and the results are obtained in the fields shown in gray. The relationship between the different variables are as follows. Point density increases as you slow down the travel speed. The density of points decreases with increasing travel speed. Point density increases with decreasing flight height, or distance to the surfaces of the objects to be scanned. The density of points decreases with increasing flight height or distance to the surfaces of the objects to be scanned. The density of points estimated on the ground decreases by having a lower percentage of light that passes through the vegetation and reaches the ground. Later at Digitizing the World.